Hello class, how are things today? We are talking about integration once again. We are wrapping up our integration techniques. We had the inverse power rule and U-substitution. We've been practicing those over the last few days. Now we are going to tackle which method is easier and maybe noticing on a test just how to do the problem, how to get started. Even if we use a harder method, maybe at least we can get it right. So let's give it a shot. Okay, solve using the inverse power rule. Okay, now, we have solve using the inverse power rule. Okay, the power rule, the basic method of finding a derivative, and the inverse power rule only applies to terms that are added or subtracted. So to use the inverse power rule, we'd have to FOIL this out. That doesn't look too bad. Okay, so we'll FOIL it out. So 2x times x squared is 2x cubed. 2x times negative x is a negative 2x squared. Negative 1 times x squared is negative x squared. And negative 1 times negative x is positive x. Okay, now we have terms that are added or subtracted. We can combine like terms if we'd like. That might save a little time. So we get 2x cubed minus 3x squared plus x dx. Now we can happily apply the inverse power rule. So it's 2 over the new exponent, 2 over 4 x to the fourth minus 3 over 3 x to the third plus, so these ones are there for emphasis now, not necessity. So it's 1 over the new exponent, 1 over 2 x squared plus c for good measure. 2/4 is 1/2 x to the fourth minus x to the third plus 1/2 x squared plus c. Nah, that wasn't too bad. All right, now solve using U-substitution. Well, if we can. All right, so we have to guess at the inner formula. Well, one of these two is the inner formula. There's not an obvious inner formula. Like if this was cubed or something, there was something inside a formula, this would obviously be an inner formula, but there's no cubed there. So there's no clear inner formula. So let's just guess at one. What if the inner formula were x squared minus x? Or we could have guessed 2x minus 1. Now the derivative of u with respect to x is 2x minus 1. Holy cow, that's what that is. So I think we've done it. If this is the inner formula, then the derivative of u, but what I mean is, I think we can write it with u's. Okay, so multiply both sides by dx. Okay. So let's try to write this integral with u's. So start with the u, x squared minus x, that's u. So put a u down. Okay, now 2x minus 1 dx is du, is 2x minus 1 dx. So we have the antiderivative of u du. And the antiderivative of u is just 1/2 u squared plus c for good measure. And u is x squared minus x. So we're saying that that's the answer, and that's the same as this. These are the same. That's what we're arguing. I don't know if I believe it or not. Which method was easier? Generally, if U-sub works, it's less steps. Now, some of you might be still not quite getting U sub, so you think, well, U sub is harder. Well, no, mathematically it's easier. It's shorter. Now, U sub in general is a tricky concept, but U sub is easier if it works. U sub is easier when it works, and you can usually tell ahead of time if it's going to work. Okay, now, I'm still a little curious if these two things are really the same. So is 1/2 x to the 4th minus x to the 3rd plus 1/2 x squared plus c, is that really equal to 1/2 x squared minus x? Oh, sorry, I just realized I forgot the squared here. There should be a squared right there. 1/2 minus x squared plus c. Do you see what I noticed I missed? Because it's u squared, I missed the u squared. I missed that squared there the first time. So are these really equal? So if you FOIL this out, if you square this and multiply it by 1/2, do you get this? Probably. I have all the time in the world. Maybe I'll check. Okay. So 1/2 x squared minus x squared means x squared minus x times another x squared minus x. Now, FOIL this out. X squared times x squared is x to the 4th. X squared times negative x is negative x to the 3rd. Negative x times x squared is another negative x to the 3rd. And negative x times negative x is positive x squared plus c for good measure. Now, 1/2 x to the 4th. Minus 1 is minus 2. Negative 2 divided by 2 is negative 1. And then 1/2 x squared plus c. So how's it looking? How's it looking? 1/2 x to the 4th, 1/2 x to the 4th minus x to the 3rd plus 1/2 x squared plus c. They are the same. I have done it. I have proved that they're the same. All right. I got to calm back down, take a deep breath, and try the next problem. All right. Where was I? I was arguing that U substitution is easier when it works. All right. Let's try this bad boy. So, the derivative of 2x squared is 4x. Ooh, that's pretty much the same as 8x. So U sub will work on this problem. Now, it's pretty easy just to distribute this. So in this problem, I might, even though U sub is generally easier, I might just have a tendency just to distribute that, because that looks really easy to rewrite it and use the inverse power rule. So I would probably go ahead and do that. Okay, 8x times 2x squared is 16x to the 3rd, and 8x times negative 1 is minus 8x. Now I can happily take the antiderivative, so it's 16 over 4 x to the 4th minus 8 over 2 x squared plus c for good measure. And then 16 over 4 is 4 x to the 4th. 8 over 2 is 4x squared plus c. I have done it. Okay. This one. The distributing it looks easy. Now, 8x squared times 2x squared is 16x to the 4th. 8x squared times negative 1 is 8x squared. Now, the antiderivative is 16 over 5 x to the 5th minus 8 over 3 x to the 3rd plus c for good measure. All right, everything's fine. Okay, now you have to bear with me on this one. I'm going to attempt to explain when U substitution doesn't work. Okay, U is 2x squared minus 1. I'll let that be the inner formula. The derivative of u is 4x. Multiply both sides by dx, and you get the derivative of u is 4x dx. Okay, now we're going to try to write it with u's. This is the step we try to write it with u's. So we have the antiderivative. 2x squared minus 1 is u. We're trying to write this with u's. Okay, 8x squared dx. Oh, we have 4x dx, and we want 8x squared dx. We need to multiply both sides of this by 2x. So now 2x times 4x is 8x squared dx. So 8x squared dx is 2x du. The 2x goes here and the du goes here. We didn't do it. We were trying to write this with u's and we didn't do it. There's an x there. This is not a minor drawback. That's a major drawback. Okay, so changing a 4 into an 8, you just multiply by 2. That's a minor drawback. But if you need an x and you multiply both sides by an x, then you can't write it with u's. So this didn't work. We weren't able to write it with u's. U sub didn't work. Okay, did you catch that? It didn't work because of the major drawback. So changing like a 4 into an 8, changing a number is fine. But when you're missing like an x, that's the major drawback. Okay. So, hopefully that made a little sense. All right, now, example 4. All right. We cannot distribute the x to all the terms and get rid of the division. There is no inverse quotient rule because in the quotient rule, you combine like terms, you can't uncombine them and see where it came from. So it's not just that we're not learning it, it's that there is none. It doesn't exist. So either U sub works or we can't do it. Some integrals you can't do, and you might get to some like how to go around that. Some computer programs give you like an estimate. There are some things you can do in an advanced math course, which we're not going to worry about right now. So some integrals are impossible. Okay, so let's tackle this bad boy. The inner formula is obviously 5 plus the natural log of x. Now, I'm not saying U sub's going to work, but I'm saying that's the inner formula. So the derivative of u is, okay, the derivative of 5, that cancels out, and the derivative of the natural log is 1 over x. Now multiply both sides by dx. So du equals 1 over x dx. Now, what were we hoping for? 1 over x dx. Ooh, it looks like u sub is going to work. So before, u sub was our only choice. So if u sub didn't work, we'd have to just give up and say we can't find the antiderivative. But it looks like u sub is going to work. By that, what I mean is I think I can write the integral with u's. It looks promising. So start with your u. So 5 minus the natural log, that's u. So u to the 5th. Now, 1 over x dx is du. So I can write the du. It always looks better at the end. So I did it. I was able to write all this information with u's. Now I can take this antiderivative. So u sub is working. Okay, so I get 1 over 6 u to the 6th plus c. And u is 5 plus the natural log. I have done it. Okay, this one, example 5. Okay, there is a product right here. Okay, so it's this times this. Now, we don't know the inverse of the product rule. For some reason, you learned that in AP Calc 2, so that might work on this problem. We haven't learned it yet. So can we distribute, FOIL it out, and get this as terms that are added? No. So our only choice is U-sub. So either this works or nothing works. Okay, let's try U-sub. So U will be the inner formula. 4x to the third plus 3. The derivative of u with respect to x is 12x squared, and the derivative of 3 drops out. Multiply both sides by dx. So du is 12x squared dx. Now, 12x squared isn't what we were hoping for. It was 36x squared. So is this a minor or a major drawback? We need to change 12 into 36. X squared is correct. This is only a minor drawback. We need to multiply both sides by 3, and we'll have it. So 3 du equals 36x squared dx. I believe we have done it. Now is where we can try to write this with u's. Let's try it, let's see if it works. Okay, write the u first. So 4x to the third plus 3, that's u. So we have e to the u. Now, we have 36x squared dx left to account for. 36x squared dx is 3 du. The 3 is going to look better in front, and the du looks better at the end. I have done it. All of this information is accounted for there. And I can take this antiderivative. Ooh. Okay, so I get 3 over the new u, what? Wait a second. E to the u, that's a special case. This isn't going to go up by 1. That's a special case, e to the u. The antiderivative of e to the u is e to the u times 3 is 3 e to the u plus c for good measure. Now, u is 4x to the third plus 3. And I've done it. Let's try this bad boy. All right. If that's the inner formula, x to the third, the derivative of that is 3x squared. Is that 3x squared on top? No. Could the top be the inner formula? Is the derivative of that the bottom? No. So U-sub doesn't work. Oh, but I can just distribute the x to the third to both terms. I can rewrite it and use the inverse power rule. So it's negative 2 x to the fourth over x to the third plus 15x squared over x to the third. And that is, so the x to the third cancels, there's an x left on top. X squared cancels, there's an x left on the bottom. So I get negative 2x plus 15 over x, and I will flip that to the top. So it's 15x to the negative 1. Now I can happily take the antiderivative. So it's negative 2 over the new exponent, x to the first. 1 goes up to a 2. Negative 2 over 2x squared plus 15 over the new exponent. Negative 1 goes up to a 0. X to the 0. Wait a second. 15 over 0 is undefined. Wait a second. Wasn't there something or other about 1 over x being a special case? So instead of x to the negative 1, what if I left that 1 over x? What's the antiderivative of 1 over x? That was the natural log. The natural log times 15 is 15 natural log. Holy cow, I have done it. Don't forget about your special case, that was a tricky one. Those are all my examples. I have done it. Some of these look like they're going to be tricky. You might need a couple hints here and there. Check your answers. Let me know. Maybe we'll work on a couple of these together at some point. Good luck.